So aggregation is using the non-fill diamond symbol on the whole part, department employee, and what aggregation means compared to composition, right? If we compare these two, let me just perhaps make some space for what I do here for the demonstration. Over here, when we use composition, and right here we have this example where we can basically take this and copy it and simply paste this in, right? So we can use this as demonstration. What it means is that department and employee are two classes which are designed separately, right? However, at runtime, when the department object is instantiated, right, the employee class should also be instantiated, right? And maybe there could be, like, most likely we're going to add the multiplicity, the asterisk on this side, right? So we can have multiple employees constructed and things like that. But the department only physically contains in memory, it only contains references to these objects, right? So the employee objects are located elsewhere. Whereas if this department and employee were arranged into the composition type of relationship, so that this diamond would be filled, right? So this, if this was a true composition with the filled diamond, we would require that employees would be placed directly inside the department, right? So in my view, the composition here is much more realistic. I'm sorry, the aggregation, right? So this is composition, which is physical containment, and this is aggregation, indicated by this diamond symbol here, that does not require physical containment. All right, so these are good things that we can indicate and show on our diagrams, because they suggest some pretty good information in terms of how to write the implementation for this type of design. So aggregation in Java and C++ compared, we already talked about this. Again, C++ traditionally inherits pointers from C, but also adds references, which could also be used for aggregating objects. And then composition in UML, of course, using the filled diamond on the whole part of side of things, and it just essentially gives you a demonstration of that. So again, we can combine the aggregation and multiplicity. There is no any kind of restriction on that, except that, of course, the aggregating part is always 1, right? So you cannot specify a different multiplicity over here, because it's just, it would be, I think, confusing to do something like that. However, on the part side, you can indicate that association has multiplicity, and you can indicate that. So that is just kind of obvious stuff, right? So here, right? So the catalog of books, right? And of course the book plays a role of item, and this item basically indicates private type of relationships. So perhaps what happens here, that maybe in Java we have an array list, which is a private object inside the catalog, and we indicate that in this type of relationship there could be 0 or more, which is so this obviously, if I use this as an example here, then we might say that basically this is kind of redundant, right? Because again, asterisk already represents 0 or more. So this is a bit of a redundancy over here, right? So we just probably want to use this single asterisk, and that would be the same as 0 dot dot asterisk, the same meaning. So composition in Java isn't really possible. Logically, you can think about it, but remember, in Java, everything every object has to be instantiated as new, and new means that anytime we say, let me just demonstrate that. Anytime we need to create, so if we have a class such as employee, right? Employee. So we have a class, but if we need to create an object of this class, which really, I tend to draw boxes, which represent something tangible, something that takes space in computer memory, right? So the process of using this class to create an object in Java, right? In Java, you always have to say new, right? New. And new is the operator in Java, and you have to say new employee, right? And you have to use constructor syntax and everything. So this will create, right? Create this object in memory, right? Number one, it will create object, and number two, it will invoke constructor. The constructor is always invoked. So there is no way in Java to bypass the new methodology to create objects. And when you say new, every time you create object which is completely independent of other objects. So therefore, there is no way to construct an object in such way that you construct an object of some sort that actually that internally contains another object as simply as its data attribute. It's impossible. In Java, what happens is that this object in Java will be created somewhere else, and all you can do is to have a reference, to this object, which would be located elsewhere because of the new operator that you have to use to construct the object. So true composition in Java isn't possible. So maybe in the job interview, someone could ask you this type of question, and that would be the answer to that. So of course, inheritance is a very popular and very useful type of relationship, and of course it's using this type of arrow, and of course we've discussed it many times already, in not just in terms of class relationships, but also when we deal with interfaces and abstract methods. Multiple aspects of inheritance we've already discussed. So here we just formally introduce the diagram, and in Java, extends keyword implements or rather expresses the relationship that button is a component. In C++, you have a colon, which is the syntax that replaces the extends keyword, but it also indicates the inheritance in C++ can be public, private, or protected. There could be different types of inheritance in C++. In C++ can also you can say also that there is a virtual inheritance for inheriting from multiple classes. So there is more variety on the C++ class. In Java, it's simply single inheritance, and there's a keyword that expresses that. So I'm not going to go deeply into this. Again, maybe we'll have some chances to, when we talk about design patterns, to explore other possibilities over here that exist in C++. with respect to types of inheritance. Encapsulation of a relationship, so association, aggregation, composition, they all can be public, protected, private, or friendly in C++. But generally speaking, what you can do is, so say you write your code over here, and you say class employee an employee, right? And you can say that employee has an address, right? And an address can be a different class in a different file, right? So address could have private string, street, right, and so forth. There could be all kinds of data attributes inside the address class. So in your employee class, maybe all you do is basically say address, right, and address, and provide this address reference, which basically references an object of a different class, right? But what this suggests here, that of course we all know that most likely you want to keep this private, right? But you could make it public or protected, and that's just basically an idea that in software you can make those choices, right? So that is just an indication that these choices do exist when you deal with composition or aggregation or association. These choices do exist, but most likely you want to keep all of the data members as private, and that's just what is perhaps this will be like 95% of cases. This would be your choice for any kind of data attributes, because remember, association, aggregation, and composition is based on data attributes, right? That's what these types of relationship internally in software represented. So inheritance in Java is public, and that's the only type of relationship. So perhaps I can say a few words about this type of thing. So say that I'm dealing with some kind of design of an existing class, and this existing class can be I don't know, maybe I already have a class that is named string, okay, which is very likely to be the case. And whatever string does, there is a class, right? But I would like to implement my own class, right, that represents a constant, immutable string, right? So I can say constant string, or I can say immutable string. And somehow I want to optimize something, or do things differently, but I still want to perhaps if this is a class name string in my UML, and this is a class name immutable string, most likely I want to use inheritance, right? I want to use inheritance. So what's going to be happening in Java, right? So in Java, what I will do in this case, right? So instead of doing it over here, I will simply say extends, right? Extends string. String, immutable string, extends string, and then I write my implementation for immutable string, which is different kind of string, constant string, which doesn't allow any changes. Perhaps you construct an object once, and then it doesn't allow any changes, right? So so this is in Java, this type of inheritance is public, which means that anything that is public, any public a member of class string becomes automatically becomes available over here in the immutable string, right? So, and it continues to be public, right? So the user of immutable string, if there was some kind of public X data member available inside the string, so this X is still accessible from the outside. So if I have some kind of client that's using immutable string and it wants to get to X, X is available because it was originally declared public. This is what public inheritance means, that everything that's public and you're inheriting it because you're saying immutable string extends string, then the client, when they instantiate immutable string, right, they will still have access. There is no way for you to make this private. It's going to continue to be public for anyone who wants to use immutable string. Okay, so in C++, if we switch over to the C++ realm, over here you can say that the default and normal type of inheritance is public, right? And this is what happens in C++ instead of extends keyword, right? But you can make this private, right? And in private inheritance situation, everything that's private in string, public in string, becomes private over here, right? So you intentionally say, well, no, this client of my immutable string can no longer use public elements of string, which is the base class or superclass for immutable string, right? So this is what private inheritance means. Private inheritance means that you want to really rewrite the interface of this class. You say, yes, this string does exist, and I do want to use everything that string does in my own class, but guess what? I'm using private inheritance here so that I provide all new methods to communicate with immutable string, and my new interface, my brand new interface over here will have nothing to do with interface of string, right? But internally, I rely on its implementation because I actually derive immutable string from the string, right? So really, private type of inheritance exist in C++ in order to redefine the interface, redesign an interface, adapt the object, but then provide different methods to communicate with that object. So there's this twist in inheritance. In Java, all inheritance is public. So that type of functionality is discarded by Java, and basically that's the case. So we already talked about abstract methods, so we're just briefly going to go over the idea behind abstraction just one more time, very briefly.